We are given the problem. Use implicit differentiation to find dy dx in terms of x and y. The function we are given, 2x squared y equals 5x to the third minus 3xy. So we have to differentiate everything. I would first separate the coefficients from wherever we have to use product rule. Now, differentiate everything. Now, differentiate with product rule. Now, redistribute the coefficients, 2 and negative 3, back into the product of the product rule. What we are left with is 2x squared dy dx plus 4xy equals 5x to the third minus 3x dy dx minus 3y. From here, we want to get all terms that contain dy dx to one side of the equal sign. Now what we are left with is 2x squared dy dx minus 3x dy dx equals 5x to the third minus 4xy minus 3y. We can now take a dy dx out of the term on the left. Now take this term in the parentheses and divide it from both sides. So what are you left with? 5x to the third minus 4xy minus 3y all over 2x squared minus 3x. We are given the problem y equals parenthesis inverse cosine of x to the fifth parenthesis to the fourth. We are asked for dy dx. The first step is do the chain rule. So 4 times the outside of the original function, and to the third, because of n minus 1, derivative of the inside, which is 1 over square root of 1 minus x to the fifth squared, times the derivative of the inside of the inverse cosine, which is 5x to the fourth. So now we are left with 20x to the fourth all over, well, times cosine, or inverse cosine, of x to the fifth, all to the third, all over square root of 1 minus x to the 10th, which is x to the fifth squared. We are given the expression y equals log base 5 of 2x to the fourth over 3x to the third plus 2, all squared. So, using our log rules, we can immediately separate this out so that it's easily differentiable. We bring the 2 to the front, and we separate the dividend and the denominator using log rules. This gives us 2 log base 5 of 2x to the fourth minus 2 log base 5 of 3x to the third plus 2. Now, we can differentiate each term separately. So we end up with 2 over ln of 5 times 2x to the fourth times the derivative of the inside, which is 8x to the third, minus, now the second term, 2 all over ln of 5 times 3x to the third plus 2 times the derivative of the inside, which is 9x squared over 1. Multiply the fractions together. You end up with 16x to the third all over 2x to the fourth ln of 5 minus 18x squared all over 3x to the third plus 2 ln of 5. And if you'd like, you can simplify the left expression to 8 over x ln of 5 by canceling out the x to the third with the x to the fourth and 16 with 2, leaving you 8 on the top and x on the bottom.